Hi guys, it is Mrs. Scott here. So today we're going to cover section 3.1, which is about identifying pairs of lines and angles. So by the end of the lesson, you should be able to answer the question, what kind of angles does a transversal create? To get started here, we're going to do just a little activity involving parallel lines, skew lines, perpendicular lines, and so on. So using this cube to the side here, first example, we're going to name a pair of parallel lines. So remember, parallel lines never intersect. So I'm going to use line CD, and then parallel to that line, we would have this line over here, line AB. All right, so those would never intersect. Now, a pair of skew lines, skew actually also means that they're never going to intersect, but they're not parallel. So they're actually in different planes. So for example, I could use line CD and line EH would be an example because those are not parallel to each other, but they still will not intersect. So CD and EH would be an example. And there's lots of examples. Line AG, this diagonal line on the side of the right hand, and line CD, those would never intersect because they're not in the same plane. So two lines that are not in the same plane will never intersect, and we call those skew lines. A pair of perpendicular lines. So I noticed that line CD, and remember perpendicular means they form right angles. So I see right here line DA is perpendicular to line CD because we have this right angle symbol in the corner. Okay, a pair of parallel planes would be opposite sides of this cube. So for example, the top of the cube we could call plane ABC, and the bottom of the cube would be plane HGF. So those two planes would never intersect, kind of like if you think of the top and bottom of a box. All right, last one, a pair of perpendicular planes. I see that the top of the box, so plane ABC again, is perpendicular to any one of the sides of the box. I'm going to use the front of the box, so this plane on the front here, which would be plane AHE. Okay, so those two planes would be perpendicular. They meet at a right angle. Okay, lastly, let's look at, or not lastly, just next, we're going to look at a few definitions. So we just kind of briefly touched on this. The first thing is parallel lines. So parallel lines look like this. And to know that these are parallel, what we have to do is put some arrows on each of these lines, just somewhere in the middle. Okay, this is the symbol. So it kind of looks like the number 11, but that means parallel to. And the definition is that they never intersect. They're always in the same plane, and they go in the same direction. Okay. Now skew lines, on the other hand, if we take a look at those, you have to have two parallel planes, or just two planes in general, and then if you draw two lines in those planes that are not parallel, that's what we call skew lines. So they are, they also never intersect. However, they are in different planes. And lastly, they also have to go in a different direction. So they're not parallel, even though they don't intersect. Okay, let's look at perpendicular lines. So perpendicular, that means they make right angles. So just draw a couple perpendicular lines here. And they have to have the box in one of the corners. The symbol is an upside down T. And those are simply two lines that meet at right angles. Okay. Now the last last two definitions deal with planes. So the first here, parallel planes, would be like these planes here. You can imagine the floor and the ceiling. Still use the same symbol, parallel to, and it's two or more. So you could have multiple planes that never intersect. Okay, so that would be like the floor and the ceiling or opposite walls, anything of that nature. All right, lastly, we have perpendicular planes. So this one's a little tougher to draw, but start just by drawing a plane, and then we're going to draw a line straight up like so. And there's the other plane, and I'm going to make a dashed line here, do a little erasing. Whoops, not that much erasing. And I'm going to make this portion dashed as well. Okay, so for these to be perpendicular, we would need a right angle symbol right here to show that they are meeting at a right angle. Same symbol as perpendicular lines, and this is two planes, exactly two planes that meet at right angles. All right, so let's take a look at some examples using these definitions. So the first example, we have an activity here. So if you'd like to try this without my help, go ahead and pause the video. But we're going to move right along. So we, in the first thing, are going to sketch line K that is parallel to line L and goes through point P. So let's try that. So I have to draw a line that's parallel to line L and goes through point P, so that would be like this. And if it's parallel, I better make sure that I put some arrows on these two lines. And I have to name this line K. All right. So how many different ways can we draw a line that does this? Well, there's only one line that's going to be parallel through up to L and going through point P. Okay, let's try another one here. So we're going to sketch line J. So a third line that's perpendicular to line L through point P. So if we make a line perpendicular to line L and going through that point P, okay, and then we make a right angle symbol here. So is there any other way I could make a line that meets this line at a right angle and goes through P? Well, no, there's only one way that we can do this. So that leads us to postulates 13 and 14. Postulate 13 tells us that there is exactly one line through P, so through that point, parallel to line L. Okay, the second postulate tells us, postulate 14, that there is exactly one line through P perpendicular to line L. Okay, so those are the two postulates that we are going to talk about in this lesson. All right, go ahead and flip to the next page. And if you take a look at this activity, we're going to use a ruler to draw two parallel lines. So I'm going to kind of do that freehand here. So we have these two parallel lines. Let's get rid of this. And we're going to draw a third line that cuts through those two. So if these are parallel, I do need to put a couple of arrows on one end to show that. And that line, this third line that we drew through the other two, is called a transversal. So we're getting to that essential question. And we're going to cut that into 8 angles. So let's call this first angle here 1, 2, 3, 4, and then we've got 5, angle 6, 7, and 8. Now, what we should do is also, we're just going to talk about some different kinds of angles here. So these create 8 special angles that we're going to talk about quite a bit. Corresponding angles, I think of corresponding as matching angles. So that would be ones that are in the same position, like angle 1 and angle 5. Or if we look at angle 2 matches with angle 6. You can see like they're in the same position. Okay. Also, if we look at angle 3, that matches with angle 7. So we could use that as an example. Angle 3 and angle 7. And the last one, 4, matches up with 8. So angle 4 and angle 8 would be the last set of corresponding angles. All right, alternate interior angles are opposite inside angles. So, for example, 3 and 6 are inside the parallel lines and they're on opposite sides of the transversal. So we could use angle 3 and angle 6. The other option, 4 is also inside and 4 is opposite to 5. So we could say angle 4 and 5 are alternate interior angles. Okay, alternate exterior would be opposite outside. So alternate just means opposite, exterior means outside. And those would be, if we look at angle 1 is on the top, it is opposite and outside in relation to angle 8. So angle 1 and angle 8. The other outside angle would be angle 2, and that is opposite angle 7. Okay, so angle 2 and angle 7. And the last definition that we'll look at is consecutive. Consecutive means same side, and interior means inside. So 4 and 6 are on the same side, and they're inside the parallel lines. So that would be one example, 4 and 6. And the other example, 3 and 5 are also inside and on the same side. So we would call 3 and 5 consecutive interior angles. All right, so what I would like you guys to do is, if you notice here that the two lines that the transversal crosses don't have to be parallel. So that's important. So if you look at this example below, that's kind of showing that here. So we're going to see if we can find all the possible pairs of these types of angles given that line K is a transversal. So let's go ahead and start with corresponding angles. So if we look here, it looks like angle 1 corresponds with angle 5. So that would be one example. Angle 1 and angle 5. I also notice that angle 2 corresponds with angle 6. So angle 2 and 6. And we have angle 4 corresponds with 8. angle 4, and angle 8. And the last pair, 3, corresponds with angle 7. So angle 3 and angle 7. All right, so let's flip to a new color here. Let's look at the alternate interior angles. So those are opposite inside. So if I look at inside these two lines, well, inside of these two lines is everything in here. So if I use 4, that is opposite 6, and those are both in the highlighted region inside. So angle 4 and angle 6 is an example. And the other example would be 5 and 3. Those are inside and on opposite sides of the transversal. So 3 and 5. Okay, let's erase this so we can start over. Now we're going to look at alternate exterior angles. So when we talk about that, we're still looking at these two lines. And now we don't want to look at the outside part, we want to look at the exterior. So the exterior angles are outside of these two lines. So we have angle 7 and 8 and 1 and 2. So angle 1 is outside and its alternate is angle 7. So angle 1 and angle 7 we call alternate exterior angles. The other pair we have are 2 and 8. So angle 2 and angle 8. And now we're going to look at coupled pairs of consecutive interior angles. So if we look at interior angles, remember we're looking inside of these two lines. So again, we've got angles 3, 4, 5, and 6. All right, so consecutive means same side. So if I look at angle 4, angle 5 is on the same side. So that would be a pair of consecutive interior angles. And lastly, 3 is on the same side as 6. All right, so there's just a few new definitions here. If you guys have any questions, please ask. Thanks for watching, and we'll see you next time.